Okay, so with the dynamic list, you should be able to increase or decrease the size of the list at runtime. Now, the way we are going to do that is this. Okay, let me go to the code right away so we can then analyze it. Okay, so these are the member variables you're going to maintain for dynamic list. So remember, for static list we just maintained the pointer to the array of integers. So in addition to that, we are going to maintain two member variables called max size that will store the maximum size of the list, which is the size of the array, uh, as well as the end of array is a variable that will store the index of the last value returned to the array. So the index of the last element in the array. So why I say that is, for example, you could have, say, max size in this case to be, say, 8. There are 8 there is space for 8 integers to be stored in the array, so the max size is 8, whereas the index of the last element in the array is going to be 4, because this is, say, index 0, then 1, 2, 3, 4. So end of array would be 4 if you consider this block of integers as a list. So end of array is going to be 4, whereas max size is going to be 8. So as a constructor, I have to initialize its values. So I pass the size of the array as input, or size of the list as input. Then max size equals that size. So array is going to be now a pointer to an array that can store this max size integers. So is equal to new int max size. So you are creating a block of memory that can store that many integers, max size. Now we have just created the array. We have not yet set up any initialize the content of the array. So the end of array variable will be initialized to -1. So this itself will give you a clue. If you want to check if the list is empty, I can have an isEmpty function that will simply check if end of array is -1. If end of array is -1, we can return true, indicating the list is empty. Otherwise, you can return false. So in return false, it means the list is not empty. Okay, so if end of array is -1, that means there's no element in the array. So that's why I return true, indicating the list is empty. Alright, so one second. Okay, so we'll now start with list ADT. So by the way, an ADT means abstract. Alright, so now I can have the delete list function that will simply delete the array that we created. So we'll clear the memory. Alright, so let us now see how we are going to insert an element at a specific index. Remember, this is what is the motivation of why we needed a dynamic list compared to a static list. Alright, so the way we are going to do that is this. So assuming that we have sufficient space in the array to insert, so let us say this is the array before the insertion, and I want to say insert 30 at index 0, so that means everything else should be shifted to the right. So the way we are going to do that is we are going to shift everything. So as I said, I'm assuming that there's one more space, at least one more space available in the array. So this is where the index is corresponding to the end of array. Then that means I also have, I can insert, or I can write something to the index next to end of array, because I'm assuming there's sufficient space in the array. So that means now I can start from the right, starting from end of array. I make a copy of the value at end of array, and write it to the next index. So that means end of array plus 1, this index will also be 20, the data will be 21. So this will also be 21 for that at that time, but now I do this repeatedly from the right to left. So if there's a value 47 before the 21, now that value will be returned to the index end of array. So we keep doing that, so that means 23 will also be copied to the right. So you will overwrite 13 and become 23, but by the time you would have copied 13 to the right. So because that's why we are copying things from the right to left. So 17 would be copied to the right first, and then 13 will overwrite 17. Then 23 will overwrite 13. Then 10 will overwrite 23. So that means that's why I indicated here. So you will have 10 at both index 0 and 1. So that's the time you overwrite at index 0 10 with 30, because that's the index where you want to insert. Now in general, if you want to insert at index I, you will shift from the right all the way only up to that index I. You will not go all the way to 0. So again, remember, you're shifting things from the right, starting from that rightmost index, which is end of array. You will copy that value to the right and proceed to the left. Okay, so that's how you do insertion. So let us look at the code for this. So you want to insert at a specific index to the list. So insert index is where you really want to insert and the data. Now remember, end of array is where you have the last element in the list currently. So at the worst case, you may want to insert, not the worst case, in the sense that the one possibility is in one extreme, you would want to insert something to the end of the list. So the end of the list is currently end of array, so you want to insert something to the end, next to it. So it means the index of the element that you would insert next to end of array would be end of array plus 1. It cannot be more than that. Okay. So if insert index is greater than end of array plus 1, so that can happen only if the user will wrongly enter the value for insert index. So this is like a self-healing code. This will reset insert index that was kind of input by the user to end of array plus 1 in case if the user inserted something, or if the user mentioned something greater than end of array plus 1. Okay, because that's the maximum possible value of insert index could be. Now once that thing is done, you can really start inserting. Now but before you do that, you have to make sure there is sufficient space. So how we check that is, check if end of array equals max size minus 1. If end of array equals max size minus 1, that means the last element in the array is at index max size minus 1, which could be the maximum value of an index in the array, because index ranges from 0 to max size minus 1. So if end of array equals max size minus 1, that means the array is full. You cannot insert anything to the array. So that means it's the time to resize the list. Okay. So this is how you resize the list. So let us assume the list currently has space for 4 elements. So index 0, 1, 2, 3. So end of array is 3, max size is 4. End of array equals max size minus 1. And let us say original array is the name of the array pointer pointing to the first element in this list. So it's at the value of original array will be 108, because that's storing the address. Now what you do is you create another pointer that will take the value of this original array, so it means it's also pointing to address 108. Once we set it up like that, then we can create a new block of memory whose size will be double the size of the previous array. So it is now 4 elements, it will be 8 elements. So this new block can store 8 integers, and you're making the original array to now point to this address 144. That is the address of the base address of this new array that we created. So we still have a handle to this original list using this temp array. So using the temp array as a handle, you can copy the contents of the previous list to this current list. So everything will be copied one by one, element by element. 20 here, 20, then 45, 45, 12, 12, and so on. So you can access this list using original array, you can access this list using temp array. Now the max size for this list will be double of this, and end of array is still at index 3, so end of array will be 3, and you can now insert wherever you want. So if you want to insert as a element as a last element, then you can just insert after end of array, and after you do the insertion you increment end of array so that it is now storing the index of the last element in the list. You could insert it anywhere you want, okay, because using the logic that we just saw, if you want to insert somewhere other than the end position, you can shift things to the right and then insert. Okay, so let us look at the resize code, because if you want to write something to the list, if the array is full, then you have to resize the list first before you can write. So as an argument to the resize function, I am passing 2 times max size, so because I want to double the list size, and later we'll see why it's a good idea to double rather than just increase the size of a list by 1. Okay, so this is the resize code, and as I said, you first create its temp array pointer that will store the base address of the original array in the list. Then you're refocusing this array to point to this new block of memory, and the size of that block is going to be s, the value you pass to this resize function. So if you pass 2 times max size, that's the size of this block of memory, and the array is storing the array pointer is storing the base address of that block. So now you go through a for loop to copy the content of the first list to the second list. So index 0 to index less than minimum of s end of array plus 1. Now the reason why we do that is, with this kind of generic code, you can also reduce or shrink the size of the list. So let us say if the list size is max size is 4, then 2 times max size is going to be 8. So s will be 8, end of array is 4, 8 and 4 plus 1, so end of array is 3, right? Because you had only 4 elements, 0, 1, 2, 3. So end of array is 3. So minimum of say 8 and 3 plus 1 is 4. So basically you run the loop for index 0 to index less than 4. So that is equal to just running 0, 1, 2, 3 and copying the content of the first list to the second list. Now, if you want to shrink the list size, say from instead of 4 elements, you want to make it just say 3 elements, then minimum of 3 comma end of array plus 1, 3 plus 1 is 4, so minimum of 3 and 4 is 3. So that means the loop will run for index 0, 1 and 2, because index is less than 3, you will stop. So that means you're copying only the first 3 elements, 0, 1 and 2, to this new list. Okay, and not only that, remember that is the value of s, the 3, so that means the new list really has space for only 3 elements. Okay. Alright, so typically we don't do that, but the code is more generic enough to deal with that situation too. So typically we'll increase or double the size of the array. Alright, so then we can set max size to be this s. So this resize code is also a code in the list class. So once we are done with that resize, now the list has sufficient space to take up an insertion. So this is what I said, you kind of keep shifting things starting on the right to the next position. So index equals end of array, and index. So you keep doing that until you reach it, insert index. So index greater than equal to insert index, and index minus minus. So basically you're copying array of index plus 1 equals array of index. So whatever is at the value index, you're copying that to index plus 1, and you keep doing that starting from the right. So that's why you do from end of array and keep moving to the left. And once you reach insert index, you come out of the loop. If once index becomes less than insert index, so that's the time you come out of the loop, and at that insert index you can write the data, because by that time the data at insert index, the previous data at insert index, will have been copied to the right. So you can overwrite that value with the data that you want to insert. And so like in this case, if you want to write this 27 here, then 17 would have been shifted to the right, 12 would have been shifted to the right, 45 to the right, and 20 would have been shifted to the right, and this is you have reached insert index. Then you can write here 27. So either way, then there is an addition of one more element to the list, so end of array needs to be incremented by 1, so it is always pointing to the last element in the list. So that's why I do end of array plus plus. Now this code will handle inserting at any index in the array in the list. Now if you really want to insert only at the end of the list, okay, then you can have another function called insert function that will always insert only at the end of the list. So you just check if end of array equals max size minus 1, if not resize, and then say array of plus plus end of array equals data. So end of array is currently pointing to, or currently referring to the last element in the list. You first increment it, and you have space in the array, so array of plus plus end of array, the new value of end of array will be end of array plus 1, and at that index you write the data. Now this is called pre-increment, so end of array is also incremented, and then you're accessing that specific index. So let me see, you can stop with this.